Achieving homogeneous mixtures. The amalgamation of powders is a widespread practice across both industrial and everyday contexts, driven by the universal importance of homogeneous mixtures. In industrial applications, this process is indispensable, particularly in fields like pharmaceuticals, food production, and chemical manufacturing. The creation of homogeneous mixtures is critical for ensuring the uniform distribution of components, underpinning the pillars of product quality, consistency, and performance. Similarly, in our daily lives, the act of mixing powders is a routine occurrence, notably exemplified in culinary activities. Take, for instance, the blending of flour, sugar, and other ingredients in baking, where a homogeneous mixture is the key to achieving the desired texture and taste in the final product. This occurrence is mirrored in the natural world as well, where the blending of soil components within ecosystems is a vital contributor to the maintenance of the delicate equilibrium necessary for optimal plant growth. The significance of homogeneous mixtures extends to our existence, both within industrial applications and the natural world. This significance is rooted in their inherent ability to consistently deliver desired outcomes and attribute in-demand characteristics to products. Understanding the fundamentals of powder mixing and blending. Uniform mixing involves the process of combining different powdered components to create a homogeneous mixture, where each particle is evenly distributed. The science behind achieving this homogeneity is far more complex than one might imagine. Uniformity in powder mixing is not a matter of chance but is driven by a set of key principles. These principles are the foundation upon which successful mixing and blending operations rely. One of the most critical factors influencing uniformity is the particle size distribution. Smaller particles have a higher propensity to blend seamlessly, ensuring that each ingredient is evenly dispersed throughout the mixture. Manufacturers often employ particle size analysis to precisely control and confirm the desired particle size distribution, thus achieving precise and consistent powder characteristics. Adequate mixing time is another fundamental aspect whereby over-mixing could lead to segregation, while under-mixing could result in incomplete blending. The ideal mixing time varies depending on the specific materials being blended, their specific characteristics, and the equipment in use. The order in which different components are introduced is another factor that can significantly affect uniformity. Mixing should be systematic to prevent clumping or poor dispersion. The sequence in which ingredients are combined must be optimized to ensure a homogeneous final blend. Powder blending techniques. The applications of different powder blending techniques are far-reaching and span a wide spectrum of industries. In the pharmaceutical sector, for instance, uniform blending is not merely a matter of preference but a necessity. It is indispensable for ensuring the consistent dosage and efficacy of medications, critical for patient health and safety. Pharmaceutical manufacturing relies heavily on a range of specialized mixing equipment, including V-blenders, double-cone blenders, and planetary mixers, to achieve the uniform distribution of active pharmaceutical ingredients. These precision-engineered machines play an important role in ensuring that the pharmaceutical powders are thoroughly mixed, eliminating the risk of hotspots or uneven distribution, which could lead to ineffective or potentially harmful medications. In the food and beverage industry, achieving and maintaining a consistent taste, texture, and nutritional content is paramount for ensuring product quality and meeting customer expectations. To accomplish this, a diverse array of blending techniques is employed, each tailored to specific requirements. For instance, in the baking sector, the precise mixing of ingredients is essential to create uniform doughs or batters, which directly influence the final texture and taste of baked goods. This entails employing equipment such as high-speed planetary mixers for thorough ingredient dispersion. For example, in the production of snacks and beverages, the creation of flavored powders is a common practice. These powders often form the basis for various products like instant drink mixes, seasonings, and flavored coatings. Achieving consistent flavor profiles in these applications is a science in itself. Food technologists use specialized blending equipment, such as ribbon blenders or fluid bed mixers, to ensure that the flavors and ingredients are uniformly distributed, resulting in the desired taste experience for consumers. Additionally, particle size and distribution play a critical role in the texture of the final product, and particle size analyzers are often employed to fine-tune these characteristics. Moreover, powder blending and mixing techniques find applications in a multitude of other industries, including agriculture, chemicals, oil and gas, cosmetics, plastics, and metallurgy, to name a few. The role of particle size. The role of particle size in powder mixing cannot be understated, as it is one of the main factors in determining the uniformity of the final blend. Smaller particles have a higher tendency to disperse evenly throughout a mixture, while larger particles tend to segregate. Achieving the desired particle size distribution is a key objective in the pursuit of uniform mixing. Manufacturers have the flexibility to choose between batch and continuous powder blending methods based on their specific needs and production requirements. Particle size plays a crucial role in how powders blend and mix, making it a critical consideration in selecting blending methods. Batch blending involves mixing a finite quantity of materials in a controlled environment, offering a high degree of control over the blending process. On the other hand, continuous blending allows for a continuous flow of materials into the blending apparatus, making it more economical for large-scale production. However, it may present challenges related to process control and the potential for waste if not managed correctly. Upgrades in powder blending equipment. The world of powder blending has undergone remarkable upgrades and advancements in equipment and technology, leading to a significant transformation in the efficiency and precision of the blending processes. Modern, high-performance blenders, including ribbon blenders and fluidized bed mixers, have been meticulously engineered to enhance efficiency and uniformity. These cutting-edge machines are purpose-built to minimize dead zones and ensure the even distribution of components throughout the mixture. The progress in powder blending equipment and technology has indeed been substantial in recent years, yet the journey is far from over. There is ongoing potential for improvement, particularly in terms of continuous and automated blending systems, sanitary blenders, solutions for challenging mixing applications, and the integration of sensors and data analytics. By addressing these areas, the powder blending industry can continue to evolve and produce superior blends with higher throughputs. Continuous blenders, for instance, enable the uninterrupted blending of powders, significantly boosting throughput and operational efficiency. These blenders find frequent application in large-scale production, such as within the food and beverage industry. Automated blenders, on the other hand, offer programmable precision, allowing for consistent and repeatable results by following specific blending recipes. Integration with other production equipment, such as feeders and conveyors, facilitates fully automated blending operations. In the realm of sanitary blenders, designs are optimized to meet the stringent hygiene standards of the pharmaceutical and food industries. Typically constructed from stainless steel, these blenders feature attributes that simplify cleaning and sanitization. Finally, high-shear blenders have been engineered to create blends with a remarkable degree of uniformity, making them particularly useful for mixing powders with varying particle sizes or densities, as well as for incorporating liquids and other additives into the mix. Challenges and solutions in powder blend uniformity. Segregation is a phenomenon where particles separate during handling or transportation, leading to inconsistent mixtures. Proper handling and storage practices can mitigate this issue. Special care is needed to prevent the separation of components, especially when dealing with powders of different sizes and densities. Agglomeration, or the clumping of particles, is another challenge. Agglomerated particles lead to uneven blending, affecting the uniformity of the mixture. This problem can be addressed by using anti-agglomerating agents and by optimizing mixing parameters to prevent the formation of clumps. The flow properties of powders can also vary significantly, and this can pose challenges in achieving uniform mixing. Powders with different flow properties can segregate or form dead zones within the blending equipment. Engineers often use flow enhancers to improve the flow characteristics of powders, ensuring that they mix more uniformly. Hygroscopicity, or the ability of a powder to absorb moisture, is yet another challenge. Moisture-sensitive powders can experience changes in their flow and blending properties due to humidity. Proper storage and humidity control are essential solutions to prevent moisture-related issues in powder mixing. Final words. The challenges in achieving uniform mixtures still exist and will continue to exist, despite the advancements in technology and our expanding knowledge of the science behind powder blending. The pursuit of achieving truly uniform mixtures remains an ongoing journey. The world of powder characteristics is an ever-evolving territory within an infinite landscape, with new discoveries leading to other challenges. Just as we have uncovered the world of nanoparticles, we can anticipate that the next few decades will unveil even smaller and more promising elements in some form or other. This process of exploration and research is perpetual, reflecting that there is always more to discover than we think we already know.